Alright, this is a step-by-step tutorial on doing the Alg2 trig review for evaluation, equations, inequalities, absolute value, and properties. So we look at the first one. They're solving an equation for us. We need to identify which steps they use. Here they distributed the 3, so that's going to be H. Step number 2, looks like they are adding in a negative 12 to both sides, so that's the addition property of equality. From 2 to 3, they added in these parentheses here, so they regrouped the problem. That's the associative property. Where is that? There it is. I. For 12 plus negative 12 got replaced with 0. 12 and negative 12 are opposites, so that's the inverse property of addition this time, because we're adding here. Alright, from 3x plus 0 to 3x, the 3x didn't change even though you added 0 to it. So since it didn't change, that is the identity. And since we added 0, it's going to be the identity property of addition. Alright, technically this is substitute. It should say substitute instead of simplify, but that's alright. Down here, we are multiplying both sides by 1/3. So that's the multiplication property of equality. Step 7. We 1/3 times 3 ends up giving us 1. 1/3 and 3 are opposite, so that's the inverse property of multiplication. So that's going to be A. And then here, 1 times x is just little x. The x didn't change, so that's the identity multiplication. Alright, scooting on down. We want to know, how is the multiplicative inverse and the multiplicative identity related? Well, the idea is that any number times its multiplicative inverse yields the identity. That's it. So basically it's saying any number, call it A, times its inverse, let's call it 1 over A, always gives you the identity, which is 1. So any number times its inverse equals the identity. So here's a number, here's the inverse, and there's the identity. Okay, scooting on down. We know that A, B, and C are non-zero. A and B are multiplicative inverses, so these guys are opposites. And A does not equal B. Then we also know that C is the multiplicative identity. So basically when you see that, it's telling you that C equals 1. So think about 1 times some number equals 1. That's not necessarily true. Let's just, to help us out here, let's just call A 2 and let's call B 3. So this would be like 1 times 3. Does that equal 1? Of course not. Let's go 1 times 3. Does that equal 3? Yeah, sure it does. And that'll work for any number that you plug in instead of 3. A times C equals A. Let's say we call this was 2, 1. 2 times 1 equals 2. Sure, because when you multiply anything by the identity, it doesn't change. A times B. Oops, I'm sorry. I lied. A and B are inverses, right? So these can't be 2 and 3. Let's call them 2 and 1/2. So when these guys are inverses, they cancel out. 2 times 1/2 equals 1, which is the identity. That's true. Now, does the identity times itself equal the identity? Sure it does. 1 times 1 equals 1. So the last 4 were true there. Alright, solving this equation, this is algebra 1 style. We got 10x plus 10 if you distribute. Alright, combine like terms, I'm going to subtract the 6x from both sides. And at the same time, I'm going to subtract the 10. So then I end up with 4 equals 4x. Divide by 4. And x equals 1. Patty cake. Over here, fractions. I know you guys love fractions. I'm going to put the 1/2 in for a. Minus 2/3. And c, we say, is negative 1/3. Okay. So in order to do that, we got to get a common denominator at the top. The best number to think about, your least common multiple between 2 and 3 is going to be 6. So 1/2 is the same as 3 over 6, right? If I multiply the top and the bottom by 3. Over here, to get to the 6, I need to multiply the top and the bottom by 2. 3 times 2 will give me 6. So 2 times 2 is 4. 3, 6 minus 4, 6 is negative 1/6. Alright, on the bottom, again, I need a common denominator. The least common multiple between 3 and 6 is 6. To get from 3 to 6, I had to multiply by 2. So that's what I'm going to do in the top when I get negative 2/6. I'm going to subtract that. 1/6 minus 2/6 is negative 1/6. 1/6, negative 1/6. Anybody divided by himself is always 1. Alright. So there's fractions for you. Solve the equations for y. Need to get y by itself. First thing I need to do is get rid of this fraction here. So I'm going to multiply both sides by 2. So then on the left side I'm going to have 2t equals 3x plus y, which is nice because these 2's canceled out. Subtract 3x. 2t minus 3x is just 2t minus 3x, no big deal. Which equals y. Alright. Going to keep this thing going. We need to get y by itself here, so I need to get rid of this minus 9x. So I'm going to add 9x to both sides. 18 plus 9x, well, can't combine those together, so I'm just going to write it as 18 plus 9x. Equals 3y. To get y by itself, gotta divide everybody by 3. Now you can leave it like this, y equals all of that, but in this case you can actually distribute the division. 18 divided by 3 is 6, 9 divided by 3 is 3x, and so there's y by itself. Alright, down here, blah 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 blah, we want to know what will the height of the object be after 2 seconds. Well, since they tell you that t is the seconds, we can just plug in a 2 everywhere we see a t. And we want to know what the height is, so we just need to solve for h. Well, it's already isolated, so now we're just going to simplify it. 120 times 2 is 240. 2 squared is 4. Remember, order of operations. Got to do the exponents before you multiply. 16 times 4 is 64. And that leaves us with what? 176, I think? Is that right? Yeah. So that is the height in feet. So we got 176 feet. Alright, here's the fun part. All this good stuff. Solve each inequality. Show your work. Give the solution in set and interval notation. All right. This one's already isolated. It's greater than, so we know it's going to turn out. So let me go ahead and just draw the picture. And again, I know that because of this symbol is greater than. So now it's got to figure out what the two numbers are. So I need two separate inequalities. So here we go. 6x minus 24 is greater than or equal to 12. Or 6x minus 24 is less than or equal to negative 12. Add 24 to both sides, and I'm going to have 6x is less than or equal to positive 12. Divide by 6, x is less than or equal to 4. Over here, add 24 to 12. We get 36, right? Add 24 to both sides, divide by 6 on both sides, and you get x is greater than or equal to 6. So that means here's my two numbers on the number line. In set notation, here we go, x such that x is less than or equal to 4, or x is greater than or equal to 6. Interval notation, I gotta get a start and an end point for each section. The start over here is going to be negative infinity, and it ends at 4, but it includes 4, so I need a closed bracket. Or, remember that's the symbol for or, I'm going to go from 6 all the way out to infinity. And you can't include infinity, so open bracket. Over here, it's already isolated. I'm just equaling a number, so I know my final answer is just going to be 2 points, no arrows. Let's go to work. Either 3u minus 6 equals 42, or 3u minus 6 equals negative 42. Add 6 to both sides. You end up with negative 36. Divide by 3, u equals negative 12. Over here, add 6, you get 48. Divide by 3, u equals 16. There you go. Set notation, fancy stuff, x such that.
Oh, you on the phone? I'm sorry.
Alright, so we got x such that x equals negative 12 or 16. In interval notation, remember, it's just the abbreviated set notation. Since there's no real interval between negative 12 and 16, those are just two specific points. Alright, scooting on down. Down here, before we do anything, we have to isolate the absolute value. So I'm going to add 4 and divide by 5. So let me just do it step by step. Add 4 to both sides, we get 5. Divide by 5, and I end up with the absolute value of 2r plus 3 equals 1. Now I'm ready to split it up. 2r plus 3 equals 1, or 2r plus 3 equals negative 1. Now it's just like number 21. So subtract 3, divide by 2, r is going to equal negative 1. Subtract 3, divide by 2, r is going to equal negative 2. So here's negative 2. Here's negative 1. There we go. Again, no arrows this time because it's just equals. So our set notation, x such that x equals negative 2 or negative 1. Interval notation. Same thing, since there's no real interval, we can just use the little abbreviated squiggly brackets there. There we go. Alright. Uh-oh, this one's got a fraction. However, nice thing about it is, when you isolate first, because you should always isolate first, you end up getting absolute value equals a negative number. And we all know that absolute value is always positive. Positives can't equal negatives, so this is no solution. Alright. Couple more. Isolate first. Divide by 2 is going to give you x. Absolute value of x is greater than 6. You know right away, greater than, it's going to turn out. Let me go ahead and draw the picture. When you have x minus 4 greater than 6, that's going to represent this side, or x minus 4 is less than negative 6. So, add 4 to both sides. Over here, add 4 to both sides. So then I get x is less than 2, or x is greater than 10. So, so now we're ready for set notation. X such that x is less than negative 2, or x is greater than 10. Interval notation, I'm going from negative infinity to negative 2, and from 10 off to infinity. Over here, 25, less than or equal to. Less than, I'll automatically know it's going to turn in. Since it's less than or equal to, I'm doing closed circles. Alright, so I'm ready to go ahead and it's already isolated, so I'm ready to separate it. But since I just have one region, this is the one situation where you can set up the compound inequality. Just like this region is stuck between two numbers, 3x minus 12 is going to be stuck in between the two numbers. Add 12 at all the sides, and you end up with 20 over here. You end up with positive 4 over here. Divide by 3. Oh my gosh, I end up with fractions. 4/3, in case you didn't know, is really like a little bigger than 1, right? 4/3 is like 1 1/3. 20/3 is like 6 2/3, but that's okay. We can just leave it as 20/3 for right now. So in set notation, x such that x is in between 4/3 and 20/3. Interval notation, it includes those endpoints, so I need closed brackets. There's the start, and there's the end. That's it. Alright. Again, we got to isolate first, add 16 to both sides. Even though it looks like we got equals to negative over here, that isn't going to be true once I isolate the absolute value. So I end up with absolute value of 6w plus 4 is going to be greater than 10 when I add the 16 to both sides. Alright, so then it's less than. So I can go ahead and draw the picture. It's going to turn in. This time I got open circles because there's no equal to. So let's go ahead and pin it between our two constraints. Minus 4 from everybody, and I end up with 6 over here. I end up with negative 14 over here, divided by 6. Negative 14, 6. 1. Negative 14, 6 is really the same as negative 7/3. So then I'm here in negative 7/3, and I got 1. So, oh wait, this we just got by reducing by a factor of 2, right? So then, set notation, I'm everybody in between negative 7/3 and 1. Interval notation, this time I'm using an open bracket because the circles are open. So smooth parentheses, negative 7/3 is where I start, 1 is where I finish, and another open bracket. Over here, once I isolate, 3 minus 9 is negative 6. No need to go any further because absolute value is always positive. Over here I got a negative. Positives can't be less than negatives, so no solution. And again, sometimes you might see an empty bracket. Alright, keep on hustling. Now it gets a little more tricky. This time, first off, they made it a little more difficult because they put the absolute value on the right. So if it makes you feel more comfortable, let's just swing these around. So instead of less than or equal to, now my sign is really greater than or equal to. Notice, guys, it's eating the absolute value, so it still needs to be eating the absolute value. Remember how this guy's kind of chomping away? Open its mouth, alligator mouth. All right. Subtract 1 from both sides to isolate the absolute value, and you end up with absolute value is greater than or equal to x. Now, just think about this logically. You plug in a negative for x. This is always going to be positive. This could be negative, which in that case, positive is always greater than negative, so that's true. If you plug in a positive, say a 3, 3 is always greater than or equal to 3 because of this equal sign. And if you plug in a 0, it works. So with just a little bit of common sense, you realize this is going to be all real solutions. So you can, on a number line, you just have the whole thing. Set notation, you can say x such that x is within the real numbers. Interval, you could say it's from negative infinity to infinity. It's everybody. All right. Over here, we have over here we got absolute value already isolated. So let's go ahead and split it out. It's equal sign. So I need two separate equations. X plus 3 equals 5 minus x. Or x plus 3 equals negative 5 minus x. Over here, I'm going to distribute that negative. All right. If I subtract x from both sides, these guys are going to cancel out. Subtract the 3. I end up with something that is not a true statement. However, if I go over to the right side, add x to both sides, I end up with 2x. Subtract 3 from both sides, I end up with 2. X equals 1. So this is one of those situations where, because I have this extra x on the right side, I might end up with one solution, and that's what it looks like here. Let's just double check that one to make sure that we did it right. 1 goes in, 1 plus 3 is 4, absolute value of 4 is 4. 1 goes in, 5 minus 1 is 4, so yes, they do match. So 1 is a valid solution. Set notation, x such that x equals 1. Interval notation, they're really just use abbreviated set. All right. Last but not least, you can basically use your pink chart to help you out with this, but I'll go ahead and fly through it here. You got the graphs are probably the easiest thing. Less than or equal to, you know it turns in with closed circles, so that's got to be k. Here it's equal to, it's a positive, so I'm looking for 2 dots, that's f. Less than a positive is going to turn in with open circles, that's g. Greater than or equal to turns out, because greater than or equal to a positive, turns out with closed circles, that's h. Less than or equal to, where c is negative. Positives can't be less than negatives, so it's no solution. Come back up here, so we know k is the graph, so I need something that's trapped in between two numbers and has the equal sign, so that's a. X is trapped in between the two numbers. F is just 2 dots, so I'm looking for equals, that's E. 31 is G is the graph. Well, G turns in with open circles, so I got to be stuck in between two numbers but no equal sign. Here I am stuck in between two numbers with no equal sign. So that's D. H is 2 separate inequalities with an equal sign, closed circle. So that's C, 2 separate inequalities, which leaves B for no solution. Okay, then the last one. Here I'm stuck in between with closed circles because of the equal sign. So that means I need hard brackets. That's O. Here I'm just with 2 specific values. So that's the abbreviated set notation, that's P. If I'm less than, I'm stuck inside. There it is, but this time I need the open bracket, so that's in. And greater than or equal to turns out, so I need two separate intervals, that's L, which leaves M for no solution. I think that's it. Yep. So you guys should be prepared for your test. Make sure you study. It's going to look a lot like this review. And good luck.